Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 2. Let's get started. All right, today we're going to see what happens when we multiply bases that are the same that have different exponents. And we do have a rule that we'll follow, and you can see that here. If we have any number x raised to any positive integer m multiplied by the same base x raised to the positive integer n, we get the same base x raised to the two integers added together. And we're going to see how that works just by taking a look at an example quick. So let's look at 2 to the third power. If we thought of 2 to the third power, we would say that that is also 2 times 2 times 2, okay, and there would be, that we would do that for 3 times, right? We would do this 3 times, and that would be 2 to the third power. And then we would multiply that by 2 to the fourth power, so that's 2 times 2 dot 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 times 2, and we would do that 4 times. Okay, so there's our notation we used in the last lesson. And then notice what we've had. What we have the 2 is being repeatedly multiplied, so that's our base. And then how many 2's did we use? Well, we used 3 here, and we used another 4 there. Well, 3 plus 4 is going to be our exponent. So 2 to the 3 plus 4, or if we simplify further, we get 2 to the 7th power. 2 to the third times 2 to the fourth would equal 2 to the 7th. And you'll notice what's nice is we can just look at our exponents, and we can just add those up as long as our bases are the same. So if our bases are the same and we're multiplying, we can add these two exponents to get our final answer. So let's try a few of these. Let's see, I've got exercise 1, 14 to the 23rd power times 14 to the 8th power. Well, I know that that's going to be 14 to the 23 plus 8. Okay, and I'm going to just write that in that notation just to remind myself when I'm multiplying powers of the same base, I just add the exponents. Okay, exercise 2, let's see, I've got a negative 72. Remember to put that in parentheses. Negative bases or fractional bases, put those in parentheses. And let's see, I've got my exponents are 10 plus 13. Okay. Exercise 3, my base is a 5, so that's okay. And then I'm going to add the exponents, 94 plus 78. All right. Let's see, I've got a negative number, so this is going to be a negative 3 as my base. 9 plus 5. All right, so when you get in the hang of this, maybe pause the video and solve a few on your own, and then watch the solution, see if you did it right. So I've got A's my base, and if I add the exponents, 23 plus 8, that is my new exponent. Okay, exercise 6, I've got a base of F, and my exponent will be 10 plus 13. Number 7, my base is B, that's a B, and I'm going to add the exponents, 94 plus 78. All right, and then the last one, let's see, I've got, they've done it for me, so let's take a look at this. I've got negative 3 is my base. I'm going to add 9 plus x, and they already did this, and they said that negative 3 is the base, and the exponent is 14. So what does x have to be in order to equal 14? Well, x would have to be 5. Okay, so there's the first 8. Let's look at number 9. Let's see what we've got. A little bit different now. We've got a few more terms here. So let's see. I've got a 9 is going to be my base. 9's always my base, so that's my base. And I'm just going to add all the exponents. So 4 plus 6 plus 13. So that would be it. If I add those up, I'd get 23, 9 to the 23rd. If I went all the way to simplified. And then, let's see, are all my bases are the same? Yes, so my base is a 2, and then I'm just going to add 3 plus 5 plus 7 plus 9. And if I add those up, I think that's 24, so I'd get 2 to the 24th power. Awesome, very easy to do. Once we know the rule, it's not bad, right? Okay, so let's look at a little more complicated here. Okay, so I've got bases of 4, so I'm going to start with those. 4 to the exponents are 9 and 3, so I'm going to add those, 9 plus 3. And then I'm going to multiply these 6 bases, so the base is 6. And I'm going to add those exponents, 5 and 14, so that's 5 plus 14. So that one looks like that. Okay, so that's good. We've got to be careful of our bases. They have to be the same. All right, so let's go with -4. We'll do those first. I've got a 2 and a 3. There's a 2 there and a 3 there. So this is 2 plus 3 is my exponent. And I'm going to multiply that by my 17 base, which has a 5 and a 7, so that's 5 plus 7. Okay, 13. Let's do the 7s first. That's a 2 plus 4 for my exponents on the base 7, and then we're going to multiply by the base 15, which has a 2 and a 1. Okay, that's a 2 plus 1. And just be careful here, right? You don't see the exponent 1, but 15 to the first power is 15. So I do have to add that 1. So let me simplify this further. This would be 7 to the 6th times 15 to the 3rd power. Make sure you add that 1. That one could trip you up. Okay. Let's see, what else do we have? Let's go with 14 here. We've got 2 to the 4th plus 8 squared equals 2 to the 4th plus 2 to the 6th. Okay, well, let's see. 8 squared. Well, that means 8 squared. Let's change that. 8 squared is equal to 8 times 8. And if I think of these 8s, I could change that, right? I could say 8 is really 2 times 2 times 2. And then I would have, that takes care of this 8. And then I'd have another 2 times 2 times 2. So that's 2 repeatedly multiplied, and there are 6 of them. So that is 2 to the 6th power. So this 8 squared and this, this 8 squared and this, oh boy, what am I doing? And this 2 to the 6th power are the same thing. 8 squared and 2 to the 6th power are the same. So I could say that I have 2 to the 4th, let me put it down here, 2 to the 4th times 2 to the 6th power, and then I could say that that's 2 to the 4 plus 6 power, which is 2 to the 10th. Okay, a little confusing there, but 2 to the 10th power is right. Okay, so let's see. I've got 3 to the 7th times 9, and I could rewrite this 9 as 3 squared, and then I could say 3 to the 7 plus 2. Just adding our exponents there. All right, and then the last one, I've got 5 to the 4th power times 2 to the 11th power, and these I can't do anything with. These are not the same bases. So a base 5 and a base 2, and I can't I can't multiply those together, those exponents, because the bases are different. All right, so let's move on. 17. We're going to write this in simpler form. So let's see, we've got our bases are the same. You can see that that is an x and that's an x. So I can multiply 2 times 17, that's 34. And then I'll apply my rule for multiplying exponents. So I've got x to the 3 plus 7. And if I simplified it all the way, that would be 34x to the 10. 3 plus 7 is 10. Okay, and then let's see, 18. I'm going to use the distributive property. So the distributive property just says that a times a, that's a squared, plus a times b, that's ab. And you should remember that from 6th grade. Okay, number 19, more distributive property. B times A, that's AB, plus B times B, that's B squared. Okay, and then lastly, another distributive property. You might remember this. Let me see if you if this looks familiar to you. Let me make this kind of array here. I've got, if I have A plus B times A plus B, what happens is all of these need to be distributed to each other. So I get A times A. Let me change my color here. A times A is A squared. And then I have A times B. Well, that's AB. And over here I've got A times B, that's AB. And then lastly I've got this B times B, and that's B squared. So I don't know if you remember that from 7th grade, but you get A, let me write this down here, you've got A squared plus, I see 2 ABs, so that's 2AB plus B squared. So it looks like that. And if you were using the distributive property, let me just point that out real quick. A times A squared. You might have learned FOIL first, the first, and then the outsides, A times B. Well, that's plus AB. And then I go to the second term, and I get B times A. Well, that's AB. And then B times B, that's B squared. And then I can combine these to get 2AB. A squared plus 2AB equals B squared is number 20. Okay, so if you remember from earlier, all the exercises we've done so far, we're following this law, which stated if we had x to the m and we multiplied it by x to the n, then our answer would be x to the m plus n, right? We added those exponents to get our new exponent. Now we're going to divide, and instead of multiplying exponents with the same base, now we're going to divide exponents of the same base. And you should be able to notice that, remember algebra, when you used division to undo multiplication and you use multiplication to undo division, that they're related, right? So if we have x to the m divided by x to the n, as we do here, then we should be able to subtract, do the opposite. Instead of adding exponents, now we're going to subtract exponents to get our new exponent. So let's see if that will work. Let's start with this 7 to the 9th power divided by 7 to the 6th power. I want to rewrite this a little bit. I want to say, let's make this 7 to the 9th. Let's change this to using the law that we've already learned. 7 to the 6th times 7 to the third, right? Because I could just add these exponents to get back to 7 to the ninth. So I'm going to do that, and then over 7 to the 6th power. And then I think you'll see that we can take these. The 7 to the 6th over 7 to the 6th is 1, or they cancel out, and that leaves me with 7 to the 3rd power. So my answer is going to be 7 to the 3rd power, but we can also notice that that does make it true that if I take my base, which is a 7, and then subtract the exponents, 7 to the 9 minus 6, I get 7 to the 3rd. So this does work in both directions, whether we're multiplying exponents of the same base, powers of the same base. We add the exponents. If we're dividing powers with the same base, then we can subtract the exponents. So that's gonna make our work here nice and easy. So we see here that -5 is the base, the same base, and then we're going to subtract exponents. So this would be 16 minus 7. And for exercise 23, I've got 8/5. Got to use parentheses because it's a fraction. And then I subtract these exponents, so it's 9 minus 2. 8/5 to the 9 minus 2. It's going to be 8/5 to the 7th power. And then here I've got 13 is my base, and I'm going to subtract 5 minus 4 for my exponent. All right, let's see. Let's keep going here. Let's see. Bases are the same, so A over B is my base, and then 9 minus 2, and that gives us A over B to the 7th power. A over B to the 7th power. All right, again, let's see, I've got X is my base, 5 minus 4 are my exponents. That gives me just X to the 1st power, or X. All right, 27, okay, let's see. We've got 4 squared, we've changed, right? We've changed this 4 squared. So let's see what happened here. We had 4 squared, which means 4 times 4. And then I can also think of that as, I can break the 4 up into some smaller chunks, right? Every 4 is 2 times 2, and then another 2 times 2. So that really becomes this, 2 to the 4th power. So now that my bases are the same, I can subtract. So that's the whole idea, is to make the bases the same. And once the bases are the same, I get 2 to the 7 minus 4. 2 to the 7 minus 4. Let's see, same thing here on 28. 27, let's see if we can change. They did it already, so obviously it can happen, but 27, well, 27 is, let's see, it's 3 times 9, and 9 is 3 times 3, so that's 3 to the 3rd power. So you can see how they changed that to 3 to the 3rd power. And now that the bases are the same 3, we can say the answer is 3 to the 23 minus 3. 3 to the 20th power. Okay, 29. Let's see what we got going on over here. Let's see. We've got a couple of bases. So I see 3s. See these 3 bases right here. I can do 3 to the 5 minus 2 times, and then I've got these 2 bases, so I can, right here, so I can go 2 to the 8 minus 5. 3 to the 5 minus 2 times 2 to the 8 minus 5. And again, match the bases up. So here's some -2 bases, so I'm going to go -2 to the 7 minus 5 times, and then I use these 95 bases, so that's 95 to the 5 minus 4, and there we go. Okay, we're getting there. Exercise 31, boy, we've done a lot of work, haven't we? Okay, so let's see. Let's look at this. This is multiplication, and I can think of this 3x to the 8th power over 1. So now I've got some fractions here. And I can do multiplying fractions. 5 times 3, that's 15 x to the 8th over x to the 3rd times 1 is x to the 3rd power. And now I can subtract, right? I can say, well, this is going to be 15x, x is my common base, and then to the 8 minus 3. Okay, there's the first one. And if I simplify that even further, I get 15 to the x, 15x to the 5th power. All right, and important to note that you understand that just the x is raised to the 5th power, right, not the 15. Okay, so again, I'm going to do the same thing. Let me change colors so we don't get confused here. Let's see, 5 times negative 4, that's a negative 20 x to the 6th power over x to the 3rd power. X to the 3rd times 1 is x to the 3rd. And so that gives me a negative 20 x to the 6 minus 3, which is negative 20 x to the 3rd power. Negative 20 x to the 3rd. And the last one is, again, I'm going to think of this as over 1. I get 5 times 11 is 55 x to the 4th over x to the 3rd. And that gives me 55 x to the 4 minus 3, and that is 55 x to the 1st, or 55 x. Okay, and then the last one we're looking at, and use an online calculator to multiply 2 million times 2 billion. The answer showed up on the calculator as 4e plus 21. Is that correct? Well, the 4e plus 21 is the calculator's way of showing scientific notation. So that's what that really means is 4 times 10 to the 21st power. 4 times 10 to the 21st power. And we know that that's right because if you count up all these zeros, right? First of all, you do 2 times 2, that's 4. So that's where the 4 comes from right here. And then you would count up the zeros. So we've got 3, 6, 9, 12, 15, 18, 21 zeros. And that multiplying by the base of 10 basically gets us into new place values, in our place value system. And so the 21 is represented there, and that calculator is correct. It would be a 4 followed by 21 zeros. So let's see what that looks like. There's 3, 6, 9, 12, 15, 18, 21. There's your number. And you can see why it wouldn't fit on the calculator screen. Okay, that is lesson 2. I hope that helps. We'll see you again next time.